Hello and welcome to the HPIN Learning Hub. In today's video we're going to be looking at the importance of sizing air source heat pumps correctly. If you're interested in air source heat pumps and would like to learn more, please like and subscribe to our channel as we're constantly adding more videos. So the easiest way to show you the importance of sizing a heat pump correctly is to draw a graph. So if I draw myself a little graph out, I've got my kilowatts here, and this is going to be my outside temperature. So high at the top, so big kilowatts, low at the bottom, and then cold down here, and nice and hot up this end. So this is my outside temperature, and these are the kilowatts. So if I draw my heat pump, the colder it is, the less kilowatt output it's going to give. So that gives us a graph like this. So when it's hot outside, we get nice big kilowatt output. When it's cold outside, we get much, much lower. Now my house itself, the colder it gets, the more kilowatts I need to heat it up. And you'll notice they cross over. So this point here is our MCS 100% rule, our balance point, equilibrium point. Lots of manufacturers call it different names. And here, on our temperature at the bottom, is where we size our heat pump. So we need to match our heat pump to our kilowatt of heat loss for our home. And this temperature here, depending where you are in the country, MCS give us a list of places, and you'll design the system to whatever outside temperature you get where you are. And this is affected by altitude, if you're close to the sea, how far north or south you are in the country. So that is the perfect size heat pump for us. So we've worked out our kilowatt loss as we get colder, and our heat loss of our home as it gets colder too. Now, if we were to oversize our heat pump, so fit a slightly bigger one in, then what happens is our heat pump cycles, and it goes up and down, kicks in and out, and it's a really inefficient way of running a heat pump. You also notice there that we've gone way past our line here. So we're much higher kilowatts, so it's going to be much more expensive to run as well. So if I was to undersize my heat pump, and I went a little bit lower down here, then what's going to happen is we're going to be running all the time. So it's going to be flat out trying to meet our demand of heat for our home, and it's going to get a shortfall. So our shortfall is here. So in our nice diagram of the one that we've sized correctly, we have a shortfall, and this is where our backup heater comes in. And it's much more efficient to design a heat pump system where the backup heater comes in at our design outside temperature than it is to oversize it and have it running and cycling when it's warmer weather outside. When it's cold, we've got a much bigger shortfall here, which means our backup heater is going to kick in a lot earlier on, and that's going to cause us problems with costing more money to run again. So it's really important here that we size them correctly, and you can see which size is going to match your outside design temperature. So our green line is our heat loss of our home. If we can improve the insulation of our home, we get less heat loss. And now our line meets with our lower sized heat pump. So we can, if we increase the insulation of our home, we can actually go down to a smaller size heat pump, and again it's going to be even more efficient. So the more insulation we can get, the less heat loss from our home, the smaller heat pump we can size, and the more efficient it will be. Thanks for watching today's video on the importance of sizing air source heat pumps correctly. In our next video we're going to be looking at the importance of flow rates. Thanks for watching, and if you're interested in air source heat pump installations, like and subscribe our channel for more information.